Hello everyone, I welcome to all of you on my YouTube channel. This is the first lecture on network theory. So my plan is to upload many lectures, that is the whole subject lectures of network theory in this channel. So my request you, please connect with this channel, means subscribe this channel, and if you have any doubt you can comment on comment section. I will definitely reply. So before going to start this topic, I must tell you that this subject is for two types of students. One is for graduation student who is doing graduation. Second is who is preparing for GATE examination. So this is the most important subject for this type of students. And so in network theory, dear friend, we have to first discuss about basic terms. Why we are going to study this subject? What is the application of this subject? As well as uh, what does mean of terms like network, circuits, loop, mesh. These things first I will discuss. Then I will start our main topic. So, dear friend, what is the applications of network theory? Because as we know, in our daily life, there is a circuits. Many circuits we are using. Our home appliances also using. There are you are applying voltage, and there is a current. Because of this, your bulb is glowing like that. So this is the basically connections, and this connection is known as network. So we are going to discuss such networks, and we can calculate current as well as voltages as well as powers and these things. So as you know, there are many applications of networks, so that's why we are studying this topic. Now we have to understand what does mean of network. Dear friend, network means what? As we know, we have components like resistor, capacitor, inductors. So if these components are connected in a proper arrangement, that type of arrangement is known as network. Suppose we have a voltage source, resistor, capacitor are connected in a proper way. Suppose in this way, there is a voltage RC. So this is called network. But network is not mandatory, it is closed loop. It may be closed, it may be open, like it may be like that. This is also called network. This is also called network. But dear friends, one more point we have to know, that is circuit. What is the circuit? Circuit is also one type of network, but some point should be remembered there. In circuit, there must be closed loop, and there must be current flowing in that network. If such a network which is closed loop and there is a current existing in that network, such type of network is known as circuit. Okay, so circuit will be network, but network may or may not be circuit. So this is the difference between circuit and network. I hope you got my point. Now we will discuss about some other terms like mesh and loop. I will tell you in simple language, don't worry, and you can easily understand my point, what I want to say. That what is the mesh and loop, what is the differences between that? Suppose I have an example. Let me take a color. This is the voltage source, this is the resistor, and the resistor, like that, R1, R2, R3. Dear friends, loop means what? There should be closed loop. So here we are getting closed loop here, L1, and the closed loop L2, and there is another third closed loop hole from here to here, L3. So this is called loop, means there should be closed loop. But what is the maze? Maze is also a loop, but what is the differences between them? There should be not another loop inside that loop. Means what? Suppose I am considering L3. So here inside L3 there is a R2. Means we are here you can see there is another loop is existing. So L3 is not mesh. Mesh means only L1 and L2, because inside that L1 and L2 there is no any another loop. Okay, this is called mesh. So mesh is a loop in which there is no another loop. Inside that no another loop, but loop may be anything, there should be inside loop or outside loop, doesn't matter, but there should be closed loop. Okay, so this is the difference between mesh and loop. Means what? A loop is any closed path in an electrical circuit, while a mesh is a loop that does not contain any other loops within it. So this is the definition for that. Now next topic we will discuss about uh, mesh nodes. What is the nodes? Okay, suppose here here you can see here, one second, yes, one at point 1. Dear friends, at point 1 more than two components are connecting. Means the point at which more than two components are connecting, that is known as principal nodes. Principal nodes. Okay, so this is the node, principal node, and here at point 2 is also principal node. Okay, so this is nodes or either principal nodes. One more thing, what is the branches? The portion between two principal nodes is known as branches. So from here to here, let me take another color, then we will understand. From here to here, one branch. From here to here, another branch. Here to here, another branch. So this is the branches, nodes, branches. Now next topic we will discuss types of components. Types of components. I hope all of you getting my point what I am discussing here. Or one more thing, I will share these notes in description. You can get it from there. Don't worry about that. Components. Components. There are two types of component. One is active component. Either one is this will be second point. One is passive component. One is passive and second is active components. So what does mean of passive component and active components? Passive components means what? The component which is not able to generate internal energy or internal current. Okay, the components which is not able to generate internal current or voltage. Okay, first point. Second point, the component which is not able to amplify small signals. That type of component is known as passive component. And in reverse, the component which can able to generate internal current or voltage, either the component which is able to amplify small signals, that type of component is known as passive active component. So passive components will be what? Resistor, because resistor is not able to generate any current, voltage either. Capacitor and inductor. So this is the passive component. Now what is the active component? Voltage source is active component. Current source is active component. Diode is active component. Transistor is active component. Transistor is MOSFET is also a active components. So all the semiconductor devices are active components. Along with that, voltage source, current source is also active components. Passive components, resistor, capacitor and inductor. So this is the difference between active and passive component. Now next topic we have to discuss Resistor, connections of resistor, capacitor and inductors. There are two methods through which we can connect resistor, capacitor, inductor. That thing we will discuss here. What is the two method? Suppose we have a resistor R1, we have resistor R2, we have resistor R3. So these three resistors can be connected in series manner, in series, in this way, and also these three resistors can connected like that, in this way. This is called series connection. This is called parallel connection. Okay, so suppose this is R1, R2, R3. So what will be the equivalent resistor for series? R1 plus R2 plus R3. This is called R equivalent. Now if they are in parallel, R1, R2, R3, so 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay. So this is, in this way we can calculate equivalent resistor. Now one more thing I will discuss. Let me erase this thing. Yes. Now one more thing, suppose we have two resistors are in series, R1 and R2, and we have applied voltage V across this. So we can calculate voltage at R1, voltage at R2, that is called voltage division rule. So voltage of R1 equal to R1 divided by R1 plus R2 into V, and voltage as R2 equal to R2 divided by R1 plus R2 into V. This is called voltage division rule. Now we have another chance. These resistors can be in series. This can be in parallel. In this case, we can divide current. That is called current division rule. That thing also we will discuss. Current division rule we can discuss. Suppose we have a current I and R1 resistor, R2 resistor. So what is the current in R1? I1, and it is I2. What will be the I1? I1 equal to R2 divided by R1 plus R2 into I. Here you can see, dear friend, if you are calculating current R1, then you have to keep, because there is numerator denominator, keep R2 at numerator. If you are calculating current R in R2, keep R1 in numerator, and denominator will be R1 plus R2. You can remember like that. This is called current division rule. What is the I2? R1 upon R1 plus R2 into I. So this is about resistor, how we can connect resistor in series and parallel. Also how we can find out voltage across two resistor in series and current across two resistor in parallel. Okay, now we will talk about capacitor. I will teach you slowly. If you think I am teaching slowly, you can comment me on section. I can increase my speed. It's up to you. Okay, dear friends. Now we have a capacitor C1, capacitor C2, capacitor C3. So these capacitor can be connected in series. Also these capacitor can be connected in parallel. Two method. So C1, C2, C3, C1, C2, C3. What will be the equivalent capacitor here? 1 upon C equivalent equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Dear friend, here you can see this type of equation we can see in parallel of resistor, but here in series of capacitor it is like that. So you can remember capacitor connections method is reverse of resistors. You can see what is the C equivalent in parallel? C1 plus C2 plus C3. Okay. Now we will talk about inductor. How we can connect inductor in series and parallel. So in series, if inductors are connected like that, if inductors are connected like that, L1 in series I am talking L2, L3. So what is the L equivalent? L1 plus L2 plus L3. If they are connected in parallel, L1, L2, L3, 1 upon L equivalent equal to 1 upon L1 plus 1 upon L2 plus 1 upon L3. Dear friends, if you will check this point, if we take reference of resistor, so it is same as resistor connection. So what we can conclude that resistor inductor connections method is same. If they are in series, they will add on all the resistor or inductor. If they are parallel, they will be add on in reverse form. Okay. And in the capacitor, it is not like that. So this is the way we can connect resistor, capacitor, inductor. Now next topic we will discuss about Ohm's law and then Kirchhoff's law. What is the Ohm's law? Suppose we have a resistor R and voltage V is connected across this. Suppose we have a resistor R, voltage connected V across this R, V. There must be a current, that is I. And there is a relationship between VIR, that is equal to V equal to I into R. This is called Ohm's law. Means if there is a graph between current and applied voltage, it will be linear. Okay, and this is defined by Ohm's law. So dear friend, what is about Kirchhoff's law? Kirchhoff's law, this is the most important topic. Kirchhoff's law, this is about Ohm's law. Let me write here, otherwise you will understand. This was about Ohm's law because it is given by scientist, that is Ohm. That's why on his latitude they have put the law according to their name. Okay, so just erase it. Let me erase. Ohm's law. Now we will discuss about Kirchhoff's law. There are two types of Kirchhoff's law. Kirchhoff's law. Kirchhoff's law. One is Kirchhoff's voltage law. Kirchhoff's voltage law. Second one is Kirchhoff current law. Okay. What is the Kirchhoff voltage law? According to the Kirchhoff voltage law, if there is a loop, in loop some voltages are connected. So in a loop, the summation, algebraic summation of all loop equal to 0. This is defined by Kirchhoff voltage law. Suppose there is a loop, voltage V1 is connected, voltage V2 is connected, voltage V3 is connected, like that. So according to Kirchhoff's law, algebraic sum means we are moving like that. So first we are getting minus V1, right, minus v1. Now we are getting minus v2, minus v2. Now we are getting plus v3, plus v3 equal to 0 according to KVL. Okay, so v3 equal to v1 plus v2. So according to the KVL, the summation of all the voltage in a loop, algebraic summation, you have to point out algebraic summation means if your current is moving, means delivering, that is negative. If current is absorbing, that is positive. In other case, some people consider that if delivering positive, absorbing negative, you can consider anyone, but you have to remember that what you are considering. Okay, otherwise you cannot change in middle of the question. That is the Kirchhoff voltage law. Now what is the Kirchhoff current law? Kirchhoff current law, KCL. That is called Kirchhoff current law. Kirchhoff current law means what? At a principal node, the incoming current equal to outgoing current. Suppose there is a principal node. Principal node means what? More than two components or branches are meeting that point, which is called principal node. In that principal, at that principal node, some current are coming towards the node, some current are going from the nodes. So according to Kirchhoff current law, the incoming current equal to outgoing current, or incoming current minus outgoing current equal to 0. Suppose I will give you one example. Voltage source, resistor, and the resistor, current source here also. This is our principal node. This current direction, this one, here this one, here this one. I1, I2 and I3 is flowing. So at point 1, according to Kirchhoff's law, incoming current is I1 and I3. So I1 plus I3 equal to I2. This is the Kirchhoff current law, and this follow the conservation of charge. It follow the conservation of charge, KCL. So in this lecture I will stop here because it will be long lecture, and in the next lecture we will discuss about nodal analysis, mesh analysis and theorems. And after theorem we will also discuss some waveforms, about waveforms. Then we will finish chapter 1. Then next we will go to chapter 2, that is graph, network graph. So till now we will I will complete all the subject. Now this is my duty, and what is your duty? Your duty is subscribe my channel, be connected and watch this video. So thank you so much for being here.